Okay, so now we are at the final part of the linear regression sections of this course, and we are going to discuss on multiple linear regression, which is an extension of a simple linear regression, and the application will be the same. So the first line here shows the equations of a simple linear regression, and in the multiple linear regression, we seek to extend the number of variables that is affecting the system and to get a response out of the system. For example, in order for us to move a car, several parameters need to work properly. For example, um, the petrol injection system need to be functional, compressor need to be functional, uh, the shaft need to be functional, and so on and so forth. There are multiple factors affecting the mobility of a car. So that is what we call multiple input factors affecting a single response, which is the car moving forward. So multiple linear regressions as compared to the simple linear regression is a more practical and a more widely seen scenarios in our daily life applications. So while simple linear regression is important to serve as a foundation for us to understand multiple linear regression, the applications of a simple linear regression is quite limited, okay, in our real life application. So back to these discussions of a multiple linear regression. So we know that this is the equations of a simple linear regression. And if we want to include multiple linear regression, we can simply extend this. Okay, we extend the bx to include b1x, b2x, b3x, and so on and so forth, the bk, xk. So this part is a simple extension by adding more terms behind the summations. And similar to simple linear regressions, where we seek to reduce the error, the sum of square error, the SSE, in multiple linear regression as well, we seek to reduce the error, and we perform the sum of square error. And when we obtain the sum of square error, we want to perform differentiations against B naught, differentiation against B1, differentiation against B2, and so on until Bk. And the result of it is this complicated, not complicated, I would say this huge, okay, equation for us to solve B naught, B1, B2 until Bk. So if you can notice this one, this set of equation is actually simultaneous equations. And when we put in the parameters into these multiple linear regression equations, uh, what we want is to solve the simultaneous equations, and I believe all of us can solve simultaneous equation. And by solving the simultaneous equation, then we are able to find the values for B naught, B1, B2, and so on and so forth until Bk. Because you want to get this form eventually, right? Because in a simple linear regression, we have to find A and B. And in the multiple linear regressions, you want to find B naught, B1, B2 until Bk, the value of them, right? So these are the simultaneous equations that we obtain by solving the differentiations of the SSE against B naught, B1, B2, and so on until Bk. So these are the resultant simultaneous equations that we obtain by solving the differentiation equation. And there is a trend to this simultaneous equation. Okay, let's look at the first line. Okay, the first line, we put n b naught, okay, n b naught. And then the second term of the first line is we put b1 multiplied x1. Okay, of course, the summation of x1. Yeah, to put it simply, I would say x1. But when I say x1, it means that the summation of x1 from the first I equals to 1 to n. Yeah, just before I proceed further, let's envision a system with 30 input parameters. So k equals to 30 over here. Okay, k equals to 30, x1 to x30. And in each of the x, we have 50 observation, for example. So n will be 50. So this will be the summations of x1, the first parameter, the summations of the first observations of the first parameter until the 50th observations of the first parameter. So b1 multiplied x1 plus b2 multiplied x2 plus